Hello, people. What's the best way for you to buy the witness? It doesn't matter. We get approximately the same revenue from anywhere that you get it, unless you get it in a very deep discount sale. Then we don't get that much. All right, I'm going to warm up some tea, and we're going to start attacking the Weissman target. Typically, the answer for, like, if you want to support a developer, the main difference, well, the first thing is don't pirate the game, right? And then secondly, if a game is available on a subscription service, the developer probably doesn't make any more money if you get it on that service, right? Whereas if you buy a copy, they probably get about the same deal everywhere, depending. Yeah. Really, though, I mean, the best way to support a developer, especially one without much of a reputation yet, is just to tell people that you like their game. Just spread the word about a game that you really think is interesting or good, because that's really worth a lot, especially to people just starting out, you know. Got a nutritious breakfast. Do the discounts come mainly from the developer's pocket rather than the platform? No, generally, this can vary a little bit, but generally with platforms, online publishing platforms, the discount is applied to the overall game price, but the ratio between developer and platform stays the same. So if the developer makes 70%, say, at the full price, they'll make 70% at the discounted price, usually. There can be exceptions to that, of course. That would have been a good stream title, winning the Weissman Trophy. Maybe that's for next time. What is my realistic good Weissman score by the end? I have no idea. We are already past where I thought we would get in the absence of an optimizer. So we'll see. Like, I guess I was sort of subliminally thinking we would get from the original 436. Maybe we would get below 400. Ideally, was what I was thinking. Now we're gunning for 350, which is amazing. Why is my camera so crooked? That's the question. Looks better a little bit. The LLVM debug build is still faster. That is because even that does some optimization steps that we do not do. For example, anytime you declare a string or a language built-in array type, that always goes on the stack for us right now. We don't promote that to registers at all. And until we do that, probably we're taking a speed hit. But that's really more of an optimizer thing. Okay. So off stream, I was in the middle of a big restructuring and it doesn't totally work yet. And late last night, I realized a thing that I forgot to do in it. But I'm going to try something. So what I'm trying to do is, this is the old code here and here, and this is the new code. And I'm trying to get it so I can enable the new code. Now, the problem is the new code still doesn't do a certain thing in a certain case. So what I want to do is say, we're going to go to this old system here. So we're going to say if do we have ident? Yeah. Oh. Then we go to the old system. Otherwise, we try the new system and see if that works. And if it doesn't, then we narrow things down. Okay, well, it doesn't run, interestingly. But it does compile, and it gets us a better Weissman score. So let's see. Assert false. We could see what that says. Let's see if LLVM complains about anything. Okay. I assume this will crash as well. Same way. Okay. So let's find out where this is coming from. We could probably look at the calling site, and that'll tell us which, because there's sort of three cases down there. Oh, it's not the big case. Wait, that's weird. Oh, maybe it... Okay. Why are we not going to the source window? Okay, so we're saying action.creation.entityType, where action is a pointer. Creation is a field of that. Dude, I have to get a new mouse. This fucking mouse is driving me nuts. Let me write that on my list. It's just running out of battery like every day now. It's so distracting. I deserve a new mouse. I've been working hard. Okay. It's a creation, so it's in a union. Oh. So it is in an import link. So it's actually going through the new frickin' thing that I just did. Why would that break? Oh, because it's not. Oh. Huh? Okay, hold on. Let's just put all this up here for a second. Because I'm not sure if I tested last night that runs. So we're going to do this. Weissman score is back, way back up. Okay, that does run. This is weird. So it's saying value number is not greater than or equal to 0, but it should be. Right now, all union initializers run if you don't uninitialize. We might come up with a different policy for that later. Let me pour my tea before I get hosed. That seems redundant. Bite me. I have work to do. Don't, like, guys. Yeah. All right. So no, I know what you're saying. It's just I don't want to think about or explain that right now because I want to solve this problem is really what's happening. I want to push through this and get to the point, because even after I get this working, I still have to remove all these cases and do like a new, there's still a whole piece of this that isn't there right now. So I need to figure out what's going on here. So what I want to do is just set a breakpoint for this, line 629. Problem, of course, is there might be lots of 629s, but all right. Okay. Hot loader, wrong one. Material, I don't think so, right? We're in undo. Material. Sampled animation. Undo panel. I don't think that's right. We're just in undo. Panel. Manips. I really need to narrow this down. My nips. What about my nips? Okay, jeez. Okay, so I could have done that to narrow it down. Okay. Well, let's just see what happens. Let me just see what the return value is, right? So we get offset 0, value number 22. Okay. So that's what I expected. Oh, I didn't expect that. Oh, because the import link is on the left. The import link is in action.creation. Wait, our offset is wrong. What is going on there? So we go in here. Okay, we have an ident. This is entity name. We get an offset accumulator, 0. That might be correct. This is in creation, right? Yeah, that probably is correct. Creation. Yeah, entity type is the first member. It's an offset of 0 from the start of the struct. That's fine. The left is not a pointer type. Okay. Okay, now we're at the creation part. We are looking again for review at this action.creation.entityType. So now we're doing action.creation, and we want to know the offset of that. And this has an import link. Okay, the problem is this doesn't follow import links correctly. So if we do ident resolved scope entry, right? Oh, this reminds me. There's something in the language semantics that I need to make sure happens. So, this part is the part that's wrong. Okay, good to know. Good to know. I can bust that out into just a little baby function. Let me make sure I know what to do. So we have a resolved scope entry. It has an imported by using, okay, and that has a target declaration. Somewhere. Expression. All right. And that has another linear allocation, which has an offset that we need to add. So that's offset 8. And that makes sense. So this is constant, so that's size 0. This is probably 4, and this is probably 4. Let's see, action type. Where is action type? Oh, it's right there. Yeah, okay, that's 1, and then it pads to 4 because this is 4. Okay. We understand what is happening. You know what else? Someone once said I should clean my room. All right. I think it was my mom. Might have also been Jordan Peterson. I don't know. My mom's always telling me to clean my room. Okay. Now, so we already have some code in the old system that does this. So I'm just gonna sort of port that. I don't know what to call. Sometimes I don't know what to call a function. Okay. Shouldn't be hard. Okay. Okay, so unhandled situation. Oh, I forgot. So I decided also I'm going to write a book. Hopefully not a long book. I have notes for the book, and once in a while I think about what's going to go in the book. And I just thought, okay. Okay. Everyone has fired a short book. That would be a good book. Okay. So if there's a using, we cast the using. These will probably go off. But the deal is, I wrote this code a long time ago, and it's maybe been revised a few times, but I wrote it again back when I didn't really know how the internals of the compiler were going to work and before they were revised a few times. So like often they contain like this thing here. This is probably should not be legal. If it should be, I need to record why it is. Anyway, like whatever. Like this part of what we're doing is we're rewriting this piece of functionality in order to figure it out and make it clear, make it maximally clear. So if these go off, we'll figure out how to deal with them. Okay. This should be Dagville down here. And all right. Dude, I hate typing in this thing. It's so bad. It's so bad. All right. No, don't run it. Build it. Well, I don't know if you saw that Weissman score, but that was 354,666. I think that might have actually fixed our other problem too. Well, let's run it a couple times to get a good Weissman average. 644. 639. 776. Well, I guess we have to go with that one. We are on the board with a substantial improvement in Weissman score. Congratulations, us. You're 0.5% down from last stream. Something like that. But we're not even done here. That's just an intermediate step. Like, we're not even checking in yet. Okay. Because we handled the import link thing here, I think. So this part, I feel like can go. We'll find out. Find out if that's the case. Substantially less. Feeling good about this. Feeling 7 up. I'm feeling 7 up. Feeling 7 up. I'm feeling 7 up. All right. Let's get that Weissman number update. 354195. 195. 353968. 354085. That's about in the middle. Yeah, let's take that. Okay, but we're still not even done with this particular Weissman task. There's a couple things to do. One is to hit this case down here, which still calls the old system, to figure out the deal with the old system and maybe delete all that code. Because right now we bloated our code back up. We're back over 55K, sadly. Actually, I think we were over 55K during the last stream, and then off stream I managed to delete a bunch of code. So we are back up. Okay, so down here, I kind of want to commit because this is pretty good. Let's run an LLVM test in debug just to see if it complains. And then I want to commit because the next part involves using new instructions, which was the whole reason. Not the Larrabee new instructions, but using new bytecode instructions. That was the whole reason why not the whole reason, but a lot of the reason why we did this. When we're done here, we want to use segment load plus offset. We want to say, instead of doing the CMIT expression and all that, we want to say instruction segment load plus offset -1 -1 place result, right? And then BC blah. Blah. We need a variant of this instruction that's different. Well, I guess we could return the linear allocation instead of the segment index. Let's try that. That's probably better long term for analysis purposes. For analyzing the porpoises. Okay, so we're going to do this and check in because we're doing good. Working on struct dereference efficiency. Okay, so Okay, so this is also actually going to need an if big else here too. And we can again stuff our fallback case to go to the old system into both of these. All right. So let's work on returning this other thing. So we're going to say come on, bro. Base allocation. And then maybe that's not in the header file. Of legit, yeah. That's value number return. If SA linear allocation return is SA. Okay. And we don't add SA's base address. Gotcha. Gotcha, bro. Let's see if that compiles. Linear base allocation return. I need to get rid of all these windows. I need to go back to the streaming PC setup so that I don't have as many windows. All right. Let's just make sure this works. Our Weissman score should be the same as it was, approximately. I'm just making sure that it works. Because I didn't change functionality yet. That new thing is still commented out. Okay, so now we can bring these in one at a time. So for the small values, I could do this. And then return result. And for well, we need to plug the register like that. Okay. Cool, cool, cool. Now we try this. Oh, S64 pointer. Let's change that up here. We crashed, guys. We crashed. It's so terrible. Let's see what happens. What is happening? Address is uninitialized. We have probably a stack allocation with. We have a stack allocation that's CD, 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 CD. Right? So, That didn't work. Segment load plus offset. Oh, target pointer for compiled. Oh, shit. That's what's not set. So runtime, again, we have this thing where compile time execution, in a few cases, does things slightly differently from compiled code. Apparently, this is not being set. I'm not sure for whom that is the case. Really, these shouldn't be uninitialized. Okay, so what is the deal with airplane food? What is the deal? Owning segment 0. Oh, if it's on the stack. Then we should return the value number. Segment load plus offset doesn't handle stack yet. Interesting. Okay. Probably nobody does. So here we go. We're going to go just like this. Just like we did for Lee. Lee just gives you the address and this just loads. So these two instructions are like almost the same. This should have been gone. All right. So we get a pointer either from the compile time execution or the base address plus options. By the way, we want Lee to have options as well. That has to happen. After we get this bit of Weissman score done, we're going to go back and clean that up. But we actually have to make this work with options as well. Oh, actually, yeah, we may want to do that sooner than later. Okay, so pointer. Now this is still not going to work because like the x64 backend doesn't do it. Okay, so this assert is actually not needed anymore, hopefully. Really? Still? Bruh. I need to put a little bit of a debugger system. The thing is, we're about to rewrite the loop for the bytecode builder to run with basic blocks, so I don't totally want to change that. Yet. Okay. The problem, of course, is we are crashing in an instruction after the one that's wrong. But we can go here and say, okay, we caught it, I think. No, we didn't catch it. Wait, hold on. Wait, what's the pointer? CE. Is it doing a signed compare for some reason? Like, what's going on? What is the deal? Maybe this isn't generating the instruction somehow. Maybe something bad is happening somewhere else. All right, let's just figure out where it's at. We'll look at the disassembly. Line 48 of string builder. So it's line, 48. Okay, and then I think we have some dumps in Sokoban that we could take out for now. Where's our dumps? Program, no. Wait, then who's dumping? Oh. We're going to comment out our dumps just so that we only see the one that we really want. Okay. Great. So this is string builder, line 48. Interesting, because, whoa, this is wrong. This is way wrong. Okay, hold on. So this is oh, we're not setting offset Guys. Like, or options. If the whole point was to pass the offset, you have to pass the offset. Okay. Didn't seem to wait, did I set it and not notice? Yeah, oh, it's down here. Shouldn't have let it creep down there. But, so I'm bad at programming. We're doing this load for line 46. And the problem is, is this string builder? Yeah. Buffer is base buffer dot next. So this is probably a round number. This is OX4000, right? 16384 bytes. That's another 8. So we're loading this from stack plus 4008. So this is at position 0 on the stack, hopefully. And we're 4008 into the thing. We could put a printf there if we want to verify, because it's probably the first time this instruction ever runs. So we did that. Okay, that actually looks right to me. It's the next one. Oh, it's buffer.next. No, the next one looks right too. Okay, offhand, both of these actually look correct. Okay, the problem is I don't think this thing is actually on the stack. Okay, if we switch this back, like I don't exactly know the explanatory thing, but if we put our remove me code back so that it's running, right? And we can redump, whoops. We can redump what it looks like. Why are we dumping it twice? Is it polymorphic? Yeah. No. I don't know why we're dumping it twice. So this is move v2 stack plus 4008. This is move v2 v1 plus 4008. That's the right answer, because this is being passed in a parameter, and parameter 1 goes into value number 1. So for some reason, I mean, I guess we need to check. Let's look at the old code. Maybe it didn't care that much. Okay, I know what we could do. So if we have a stack allocation, what is it? Okay. Oh, that's still got the old code. Hold on. Look how messy our code gets when we're just playing around. We're just messing around right now. Oh, it did it still. Okay, we need to just look at... Oh no, wait, it's correct now. It's V1 plus 4008. This is totally different. This is asserting that placement stack satisfied. This is like... This is like some hardcore shit. This is a totally different situation. Okay. Oh, this is dumping twice, I realize, because it's being imported once by each workspace. So this is like the startup metaprograms version, and then when we start compiling the real program, it's doing that. Okay. Placement.stack satisfied. Value placements are a pain in my butt. Okay, let me just say that. Okay. We're supposed to be not big. Oh, we need to do finish plug. This is probably why. Maybe. Now we got a different assert. Data segment not equal to null. Oh, that's just because these instructions don't handle this yet. Remember how I said not everyone can handle the truth, right? So this thing that we did here where we said, hey, if the owning segment or whatever, x64 needs to do that too, and then LLVM needs to do it too. Segment load plus offset. All right. So same thing. We'll do this. Get the segment index. All right. We're gonna set it up just like Lee above. Here we go. We're gonna say in fact, we're just going to do this. This is an improvement for a later day. And then we get the Lee. And then we do a load, and then we do a store. It's like almost exactly the same. proc pointer. What? That's a weird one. I guess we're failing a dereference somewhere. By something that's happening very late in the metaprogram. Like, what's the deal with that? Okay. We don't need this breakpoint. All right. Run foreign procedure. Run instruction. Line 494 of Windows resources. Config.enum instances, where config is a global. Oh no, it's a pointer on the stack. Really? So I'm glad to see that everybody is talking about non-technical topics. Great way to keep your brains going, guys. The way I keep my brain going is with sun chips. Let's see if we can get an easier problem to investigate. Like, it looks like we're most of the way there for this. Okay. What? Oh. I just can't really see the stack for some reason. Oh, because we're probably calling, there's this thing that happens on Windows, maybe Linux as well, where if you call through a messed up function pointer, it's really bad news. Like it hoses your stack in a way that you can't see. Maybe I can't set a breakpoint here. Maybe our debug info is just messed up. Oh yeah, our debug info is totally messed up right now. Okay. New strat. Let's get this to work on the LLVM build. It should crash the same way. So LLVM segment load plus offset doesn't do this yet. So again, we're going to do this. And then we're going to do this. If that doesn't crash in the same way, it should though. Can't tell if that crashed, but we'll do this. Okay. Hello pointer.foo of hello pointer.x. So we are not correctly doing this. Well, we can look at that. This is good because it does not involve like Windows functions in any way. So one of these is wrong, either hello pointer.foo. Let's actually make sure the rest of the tests up to lambda actually run. They don't. Okay, never mind. Or maybe don't, never mind. I don't know. Okay, maybe I messed this up. Wasn't it called lambda? Did I not ever load the file? Anyway. This does struct dereferences. Just not, okay. Well, guys, I'm just going to debug one thing at a time. We have like multiple problems. That's often very annoying or difficult. We are currently doing bug snacks, but with the direct goal of making gains. Yeah, the create store is just how we put the value in the basket or it gets the hose again. Okay, so my suspicion is we just create the wrong code for that indirect dereference for some reason that I don't totally get. So we're going to dump lambda basics. And we're going to do this. Okay, lambda basics. Okay, that's the string builder dump. That's not what we wanted. That's going to confuse me. Okay, and then we need undeclared identifier result. Yeah, whatever. Okay. Lambda basics. Lee v1 stack plus 20. Okay, so it's getting the address of hello. Oh, it's for up here for this initializer. It's clearing it for 8 bytes. Lee v2 data plus 20. That's hello pointer. They happen to both be at data plus, or at whatever plus 20. So we're storing the address of hello in hello pointer, which is this, right? So this is line 53, 53. Okay, good. So line 55 says load from data plus 20. Never mind that that's exactly what we just stored. We don't have an optimizer that could figure that out right now. So we load the same thing we just stored. So v3 has the address of hello, aka hello pointer, aka hello kitty. Now, we get a procedure value, that's fine. And we put it into v3, that seems fine. So this all kind of looks right to me. Now, line 56, the dreaded line 56. What? Oh, there's a 56 here. I was like, how is call the first instruction? So hello pointer.x is a constant, which is what this constant here is. So when we call on hello pointer.x, we're passing a constant parameter, right? Okay, so v7 comes from data plus 20. Hold on, we're getting ahead of ourselves. Get a procedure, we put the procedure in, okay. We load the, this is wrong. Okay, so this is hello pointer in V7. This is not hello pointer dot foo. So in this case, where we got back a register for the left, we're not doing the right thing. Why didn't that crash us before? I don't know. So we're using the pointer instead of subscripting. So that should be this case that we already totally frickin' handled. It should be this one right here. Which means we gave that as except it's not. It's I am bad at programming. See, this is truth in advertising. So we're generating something this should have returned a value number and didn't. That's the problem. We should not be down here. We should not be down here. We should be up here. So for some reason, that didn't work. Okay. Oh. Oh, well. Maybe that worked. Okay. This is not an... This is some lack of robustness in the test infrastructure. Let me deal with that in a minute. I have other stuff to fry first. So let's see if that goes. No. Still fucked up. But maybe somewhere different, because it passed all those tests, most of the tests. All right. I mean, I guess I can see where it's crashing and do the. Kind of don't know. Kind of don't know offhand what else the problem would be. Wait, is this set to lambda or is this set to the main game? It's the main game. Okay, so we are dying in. Oh no. We hit the stack again. Okay. Well, we could printf the values. Or maybe it's actually calling into a DLL. It might not be through here. This might be rough, guys. Let me warm up some tea while I think about what to do here. So I don't know. I don't know whether this is a setup, whether this is a crash inside our FFI calls, or whether this is us like calling a Windows function with a callback. Does access violation executing location blah? That means this is actually a page that's not mapped, right? No, actually, because it's mapped, because we can read it. So what it just means is, I don't know. It just means we dereference something invalid. Actually, we jumped. So this looks like a legit procedure. It's just we're at the wrong byte somehow. So like we jumped to the wrong location. That's not. Oh. Maybe. Let's just try that. Okay. Blah. Blah. Okay. We're going to have to put a site in here. And then pills here. Pills here. Okay. Config.enum instances. Well, I've gotten my last fizzy lifting drink out of the refrigerator. Okay. So we should have printed out a ton of things. Yes. And so I don't know how it helps me to break here, because this doesn't really give me any information. I can see the value of the pointer. Wait, is it in info? Where is it? Proc pointer. It is. Okay. It is a really messed up procedure. We should not have anything in that space. Okay, I don't even know. This probably is some like com vtable stuff. And there's endless levels of indirection that all point to each other because it's Microsoft. Now watching Blast Premiere Finals. I watched a little bit of it. I just wasn't that into it. I don't know. I saw the end of round one, but I wanted to program. Why would I be watching that while I'm making gains in the Weissman score? That doesn't make sense. Also, I kind of have this problem now in the year 2021. Like, so 2020, with all the teams playing remotely due to COVID and stuff, was very unengaging to watch Counter-Strike matches. In 2021 now, but maybe because of that break, I'm finally in this place where Counter-Strike is just too shitty to watch. Like, it's too shitty of a game in like basic aspects, like the fact that players are teleporting all the time as they like jump crouch onto discontinuities in the map, and like the fact that your bullet comes exactly out of the eye point and that grenades come like exactly out of the eye point. All these things that they made excuses for in previous design phases, where like, oh no, it's better that way because it's clearer for pro players or whatever. Like, other games that don't do that are just way better. So like, I almost just can't watch it anymore, even though I enjoyed watching it in the past. It's just, Valve needs to get off their ass and fix the game. It's so broken looking at this point. Why does everyone think that if Witness had VR, you'd have to close one eye? Guys, no. It would work fine. Think about it. Was it originally good and is now bad? I mean, it was bad it was obviously bad even back in the CS Source days, but they made excuses about it. And now it's just, ugh. Does everybody think so? No, I just keep seeing people in chat saying this. And it's come up a number of times. No, guys. The amount of parallax, if you're looking at something like, 10 meters away, the amount that parallax between your eyes affects what you see is pretty small. Like, do the math. And for playability purposes, we didn't put anything like that close to you because it would be unplayable because you'd have to like tweakily maneuver to find the right spot. So it's like all totally fine. All the pads would slightly shrink. I mean, maybe, but that's the sort of thing where you can just add a little bit of tolerance programmatically, globally. I don't know. I think it would be fine because any uncertainty is symmetric, right? So it's not like, probably symmetric. I mean, maybe it depends sometimes on where the puzzle is spatially. Anyway, it's probably fine. Like, if we tweaked it, it would be small tweaks. I'm spoiling the Witness for you. Well, if you haven't played it, you have a problem. Yeah, I could imagine doing some tweaks for playability in VR, but for the most part, it'll just work. Yeah, the head at constant height is the harder part. Like we wouldn't lock the head height because that would suck. But that's the part that might get annoying and hard to deal with. Like we would let you move, but we might calibrate your height to the character height, for example. I mean, even for stuff like, hey, you're walking up and doing this panel that's in space. If you're like shorter, we don't want you to be looking up at all the panels that were calibrated for a certain height. Or if you're taller, we don't want you looking down at all of them. So we'd probably do something like that. And then if you wanted to move your head around relative to that equilibrium point, you could, certainly. But we'd probably, re-stretch you. How likely do I think it is that hardware manufacturers introduce native FP16? If you read the Intel manuals, you'll see that they have all kinds of float formats that I don't even want to think about that they're adding. Okay. Okay, so looking at that value didn't really mean anything to me. It just does seem like the wrong thing. So we will go back and look. Again, the site is... Oh, we had info calling site. Am I stupid? Yes, we already had it. We already had it. Visual Studio is stupid for like... All right. All right, so we need to go here and not there. Get this out of my face. All right. So make sure that that still does that. Now, Windows resources, line 494. We're just going to look at what gets generated. Line 494. So config is just a pointer that, I mean, it might be wrong for all we know, but it looks pretty straightforward. It's a pointer. We call enum instances on it, which is just... Yeah, it's subscript 0. Oh, no, unknown vtable is some size probably. Let's take this out. Okay. What line did we say? It was this one, the enum instances, line 494. Oh my gosh. Okay, there we go. Okay. We do a bunch of setup variables, whatever. Let's look at 493. Okay, this is a new basic block because it's after the if, right? The if says, hey, go here. So, here, V21 stack plus 98. We should comment that with the variable name. But that's going to be instances, I believe. And then we clear it to 0. Now, we move V23 from V15. Which is, I think we're loading config off the stack. This is config.enum instances. And then this is config. This looks fine. Of course, it's not. I mean, it is not. I don't know why, though. It looks fine. I mean, maybe our offset is wrong, but I don't think so. I'm just going to step through this, right? So this is line 494. There may be lots of false positives here again. Shut up. Dude, visuals... Whoever is responsible for that is fired. What is even... All right. So we're going to get the stuff. So the offset of the entry is like 24 or something. Yeah, 24. Offset accumulator is 24. So this should say pointer to. It does. So we're not going to do this next block. We're going to fall down. We're going to emit expression. It's an identifier. We emit scope entry eval. Okay. So we pull small r value from L value. That's great. That looks fine. And again, that's whatever the config. Yes, that looked okay. We return the value number. We return offset accumulator. Okay. Offset should be 24. It is. I don't know, guys. That is the value that we keep getting. So the code, the dereference appears to be doing what it do. But like, okay. That should be one of these, though. So maybe I screwed up something before. Like that should be this case. Wait. Right? So if I revert that to the fallback scheme, do we go? Yes. We have a much worse Weissman score, but that's okay. It's because we did a thing. All right. So what I could do is compare now. Oh, no, it doesn't. Guys, I'm in bug hell now. There are multiple problems probably, and I don't understand what they're doing, what any of them are. This is very sad. Okay, so hold on. The interesting thing is the following. This used to totally work. The value number case used to work, and it was just this stuff that didn't work. So, like, what if I go back to this? Did the thing that I added break the value number case? The pointer check. Remember the pointer check? I bet it did. I bet if I, yeah. So that's broken. We can't even compile. But I bet if I do this, Yeah. Okay. So that's what I need to figure out is why does that break things? See, this should actually be wrong in that case. Like, if we look at the line 494 dump now, so 494 move V37 from V15. That's going to be config. Oh. V38 from V37. So config has the stack allocation flag because its pointer gets taken. And so right now, we don't store it directly in a value number, right? But that's supposed to have been taken care of. Anyway, so here we go. Move V37. Move V38 from V37. I think this one is right by accident. Like, I think it's only right because the offset's 0. It's the wrong. Okay. This is the L value of the thing, probably, right? So V15 gets cleared. Yeah. So that's the stack position of the guy. So we load the address of config. We load config. We load the pointer that is config.enum instances. And then we load config. Wait. Yes. So this is config. This is, wait, what? Oh, yeah. Sorry, I keep getting screwed up. Okay. V40. Wait, why is this extra dereference here then? If this V15 is the address of config. So V40 should be the value of config, which also should be V37. Why to get config.enum instances? Maybe I need to look at that more carefully. I feel like at this point, like looking at this, maybe there's been a bug in the system the whole time, generating like an extra level of indirection for things like this. And it's just like compensated for in some way. But then I don't know why this works everywhere else. Okay. I don't understand why this is V38 plus 18 and not V37 plus 18. Wait, these both say line 2579. So it's coming here twice. Okay, IUnknown vtable is just query interface add ref release. That makes sense. It's 8 bytes each. That's 24 bytes. That's fine. Thinking of storing your animation data as half float. I don't know. I feel like if you're going to compress animation data, you compress it for real and get a lot of space back. Like 50% seems like a lot until you realize that a lot of file formats compress like 100 to 1, right? So Okay, guys. So this is correct. This is the correct size. I do not understand what each of these is. Even in, this is the old pathway. I don't totally get it. So I want to get why this works. And either it works for a good reason, which then I can understand the good reason and I'll feel stupid for not understanding it, but then I can make the new thing work correctly in this case. All right. Or, which is quite possible, we may find out that the whole frickin' system was busted for like years and generating extra inefficiency. And if that is the case, then we're happy because we figured that out and made it better. That would be actually fine. Or something that's not either of those possibilities will happen. So I want to annotate these a little bit better, possibly with slow set comments or something. So 2579. Just in case. Because that could be some anonymous, I don't know. Okay. $494. vtable. Oh, right. Wait. Hold on. What? Right, this is a vtable. This is not config itself. Guys, I'm stupid. That's the extra indirection right there. Oh. Oh. So the problem is when we chase forward through usings, actually. So this part, okay, yes, this was right by accident because the things were 0. Where even am I? So this was right by accident. The actual problem is here. Wait, so this get offset of entry. If it's a pointer, we don't do this. Actually up here. So this using could be through a pointer. Aha. Yep. We are in for a bad time here. Although we set it on those. I don't know why it's only D3D blob. V stands for value number in that printout. Just value, whatever. Like I think LLVMIR uses percents or whatever to pretend to be like GCC assembly, but that syntax is really ugly. Okay. So we sort of determined the problem, but not completely because, guys, my tea has been steeping for like a year. Oh no. Yeah, it's too strong. Oh goodness. Okay, we found the problem. We are not really set up to deal with this. This is why the old version was so unfortunate. We actually have to this is a place where the language semantics being powerful are making our job harder, is making our job harder. We actually need to return n frickin' dereferences. I'm trying to think of a better way to structure this. Because like right now in my head, I have to return an arbitrary length data array that says offset. I guess it's just it is just the offset. So it's just an array of integers with dereferences between them. The problem is we're going middle out, ironically, because seriously, we are going middle out. Because we're starting with this binary tree and we're chopping the dereferences off the right-hand side down here. Chop, chop, chop. And going left. Any one of those could add multiple things going right. This is a case where if I desugared it in the front end, it would have worked better. But well, maybe I don't want to do that. I don't know. Okay, so okay, now it is time for me to warm up another tea to replace the tea that I oversteeped. While I am doing that, does anyone have any extremely on-topic questions about what I'm doing right here, WTF is going on, etc.? Where is desugaring happening now? There isn't very much desugaring in this compiler. It is something that I have stayed away from because of, like, if you desugar something into a random other structure, but you want to provide the user level metaprogram with type information about the program, you don't want to give them type information about something weird that they have no idea what it is. You want to give them their program, right? So assuming you want to do that, if you did desugar into something weird, you would need a way to map the types back to the actual things, which is maybe non-trivial or confusing or hard to think about. So I don't mostly do that. Yeah, I don't know. In cases like this, it might be fine. I'm not sure. Some dynamic array operations are hard to optimize because the front end is working with dynamic arrays as abstracted with syntax sugar. What? No. Syntax has nothing to do with it. We're not doing an optimizer right now. What we are doing is just generating higher quality unoptimized code, if that makes sense. But syntax of arrays has nothing to do with anything. Or maybe I misunderstand the question. Like, what is an example of the kind of problem that you think is there? You thought sugar equals syntax. Right, but I just said we're not doing syntactic sugar. I literally said that at least twice. This problem is made harder because we didn't do syntactic sugar for things. And this doesn't have to do with arrays really at all. What we're doing, this is struct dereferences. Off topic, but why did you think Portal was a bad? I don't think Portal's a bad puzzle game. I think Portal 2 is kind of mediocre. Portal 2 is worse than Portal 1. That is my opinion. You get messed up when your code base gets larger. How do you handle more than 50K lines of code base? I mean, this compiler is only 50K. And it's hard to deal with sometimes. I don't know. Don't have more than 50K lines. Or maybe you mean that your code isn't 50K lines. Maybe you're asking specifically about 50K because that's what this is. I don't know, man. Like, the problem isn't so much the amount of code here. Like, the complexity limit on this compiler is not really the amount of code. It's just there's certain parts of it that interact in a way that's very complicated. Yeah, we are not SSA currently. I don't know if we will be. I can think of some advantages to it. I can also think of some disadvantages. I don't know how it's going to work out. You don't really need SSA. Like, SSA is just a way to make some classes of operations more convenient. You don't really need it. Like, everything you can do with SSA, you can do without SSA. Okay. So I'm kind of thinking of some structure where we just make a data structure I mean, this is really gross, guys. And actually, hold on. I need to figure out why we're only getting this warning here. We should be getting it for the place where we crash. Let's see, because I might, if I'm not catching everything, then if I structure a solution for this too soon, it'll be bad. Get buffer size. Yeah, okay, this is bothering me actually, because this should also... Why don't we see this? And I suppose the answer is I could just step through and find out why we don't see this. I need to do that because it's weird otherwise. So this was line 494, I guess. Was that the deal? 494. So we're just going to break in line 494, which we may already be doing, yes. Okay, let's see what happens. Windows Resources 494, great. So, oh, you know what? I already screwed up. Yeah, I don't know. Let's see. I'm not sure. Okay, so we go here, we go here, we go here. This ident should be the whatever we keep looking at. Enum instances, great. So this should go through the V table. V table. Okay. Oh, maybe it just printed it first and it got drowned out by all the other ones. Oh, because it's up here. There we go. I never thought I would want so much to be in for a bad time. No, so I was just missing those. This is fine. Okay, good. Good, good, good. Mystery solved. Mystery solved. At higher level in code, less isn't always faster. Yeah, it is. Less is always faster. It's just, in higher level code, there's much more variability in how long each particular thing takes. In lower level, like at instruction level code, there is variability, but it's not nearly as much. But less is always faster. Okay, so I'm going to do something really gross here, and we're going to make it work. And yeah. Oh, this is really gross. Yeah, we're just going to do it. Let's make a tag for this, which we will call Yucky perf. Okay, we're going to have an array of dereference chain. That's a pointer. Now, if we have a pointer then I think what we do is the following. We add a dereference and then we reset the offset. Okay. Then the reason here we're going to have local dereference chain. And a total dereference chain. That's also yucky perf. And then the reason, because we're going middle out, okay? Because we're going middle out, oh God, this isn't going to work either. We pass in the offset accumulator. Okay. Okay. So we have an offset and a dereference chain. It probably should all be the same, whatever. So we pass that, we reset it to 0 and put a thing on the chain every time. Should be in the opposite order, probably. Anyway. Do I pass the dereference chain out or do I do it here? I think I pass it out. Okay, hold on. We haven't handled the middle out problem yet. Right? So we get this one. But then then we have the problem that these came in backwards. So we get our local dereference chain. If there is an existing dereference chain, we need to put this before that one. We only need to modify it if they both have items. Then we say temp.reserve this, but with a plus. And then we say okay. So we do that. Then what? Do we return it back? No, I don't think so. You know what? The smart code gen thing to do here is to not try to optimize all these. Like, look, if we get any of these, then it's fine. We just emit expression on the left. Like, we don't have to do all this. Because the reason we are doing this is to be fancy. And we don't have to be as fancy as we're doing. At some point, the complexity dwarfs the amount of win. Okay. So, we're not going to do this. We're going to say if we get any dereference chain okay. This is better. We say punt down here. We emit expression on the left. And then we say let's not even call it local dereference chain. Okay. This is starting to seem less yucky in terms of perf. We can make this fast. Okay, so if dereference chain.count for everything in dereference chain, we want to do the following. do that. Set comment BC dereference chain. Right. And then value equals result. Yeah. Why did I make this? Yeah. Accumulator. We could even yeah, I don't know. Okay. All right, this is going to be a disaster. Maybe not. Sometimes shit just works, but we could be lucky that a lot of these offsets are zero. Now, keep in mind, this is with all the other stuff still disabled. Because I had to go back. Remember, I had to go back and figure out why this was breaking things. So, like, that whole situation took some time. This looks promising, though. And it looked like we got a slightly better Weissman score, which, if we did, I will update it even though it's only a little bit lower because this has been grindy. Okay, that was actually higher. So it's about the same. Yeah, that's fine. That's fine because hopefully now we can get gains. We want gains. Okay, so these are both restored. The value number cases are restored. So the question is, can we get rid of this? And the answer is, who knows? That's gains. No, it's not gains. Damn it. It's okay, though. We'll figure it out. Okay, where were we dying? Simple string, line 104. Let's turn off this dump for a while. Simple string, line 104. That sounds familiar. Oh, no, it doesn't. Oh, no. We're going to have to actually see the call stack. Oh, actually, BTW, let's see if that helped LLVM any. It did, because that didn't compile before. Oh, no, it didn't run before. So LLVM is still busted. That might be a different problem completely. All right. Yeah, well, we don't actually get a stack when we x64. Can we compile the game in LLVM? Probably not. Maybe. But it probably won't run. It'll probably die sooner. But that just might mean that I have to shift my attention to figuring this out so we can progress with debug information. It's probably name.count or name.data it's dying on. These are probably the very first. Oh, no, that's a dereference. So we're dereferencing RCX, which is 044. Guys, I have no idea what's going on here. So name on the stack pointer is not .044. Okay, name.count is 34. We're trying to read 68 bytes in, so I'm assuming it did this correctly. And it's the .data pointer that is incorrect. Because it's 2 bytes is name. Yeah, name is UTF-16 or whatever. So that's the right number of bytes. So like somehow RCX is supposed to be name.data. Okay, let's make it just a very simple program. Right. x64 and LVM. It crashes. So like the intermediate rep is fine. Like I could even do this and it'll crash. Right? Boom. So s.data according to the debugger is hello, but again we're doing RCX plus 3 and it's 7, which is s.count. We're not adding the offset. Is that all that I did wrong? I copy-pasted it and I didn't add the offset, guys. Remember when I said that in the other? See how this says load plus offset? Plus offset. The reason I forgot it is because LLVM doesn't give us a good way to do that. Okay. If offset so we have to make a frickin' constant int. There we go. We have to do yet another frickin' cast. Okay, so we have to go gep equals gep, create bit cast, gep, comma, or I think that's what it's called. And then we need like, what's the difference between IR builder get element pointer and constant expert get I have no idea. And there's absolutely no documentation, so that's terrible. I just want to add to the pointer. We have a load plus offset actually right here. So we go, that's segment load plus offset. Here's regular load plus offset. Okay. We're going to do point PI8, and then we're going to say okay. You know what? We had an offset right down here. I guess we weren't. Oh, we had create Lee. Wait, we have create Lee, guys. Oh, except if it's a stack, this is a butt pain. All right, so we already have an offset that we can use if it's from a segment. Offset right there. Because these are already casted to the right thing. Okay, it's in this case that we don't have one. Oh, and then this cast we could leave. Like that. So if we're in here, we're going to cast it to pointer to I8. We're then going to maybe do that. I don't know. Fuck if I know if that works. Whoops. Looks like it didn't crash. Looks like we're in business. Happy day. Let's try one in the data segment. Is 121 an exclamation point? I choose to believe that it is. Okay, actually we could go to 2. Or no, sorry, is that a Y? We can go to 2 and get an E, and go to 1 and get an E, and they should be the same value. Yeah, okay, great. So let's see this on the tests. Constant stuff, and LLVM is just an inline constant folder. That's not what I'm talking about. I'm like, why do you do it sometimes through IR Builder, sometimes through constant expression, : : What's the difference? Why do I have to do it all the time anyway? Like, LLVM is just insane. LLVM is what you get when the IRS designs your API. Did they do a good job at the API design? No, they did a horrible job. Why don't people see the insanity for what it is? That's just what they think good programming is. It's an entire subculture that built this up and reinforces it constantly. And when someone hears me say they did a horrible job, somebody will come up with all sorts of reasons why it has to be the way it is, right? But this and that and that and that, and oh, it's so complicated and you have to meet the needs of all these people. And it's like, guys, that's exactly what the CEO of Boeing said for decades about spaceflight. And then Elon Musk came along and kicked his ass. Like, you can make excuses like that about anything. It's not impressive. Okay. This is good that we are running all the tests. Does that mean they all pass for x64 as well? I guess I hadn't tried it. So am I to understand then that only Sokoban crashes? How do the current tests work? They are tests that are run. And if they succeed, then we say, okay. And if they fail, then we are like an 80s cartoon henchman and say, you have failed me for the last time. Except that's never true because they always fail again later. Wait, the game run. What did I fix, guys? Maybe it's only x64 that is broken. Okay. Why does it work? Well, maybe the bug is in x64. Hey guys, this instruction is called segment load plus offset. Oh, wait. I mean, I might as well. There's actually two different places we could put it, but anyway. So that shouldn't actually matter. This isn't going to fix it at all. So we might have to like hunt down, since we don't have debug. This is where like I should have fixed the debug info long ago. Okay. So we are crashing in simple string. So I could just hope that happens every time, right? What line number? 104. So, oh. Here's where we use a trick. All right. Hopefully the print function doesn't use this, and we don't infinite loop. All right. We haven't used the trick yet. It sure works a lot of the time till it don't. Okay, the trick is this. Simple string line 113. Wait, that doesn't seem right. Simple string 290, simple string 113. All right. Oh, I bet this... Dealing without debug info. I sure should have fixed that corrupted debug info. 'Cause debug info would be good right now. Okay, so the problem is between here and the next thing. Actually. Interestingly enough. Right? Because we do this, and then we do this. We'll go here and here. We don't need to print the location because we know where it is if it comes right after. Oh. What? 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 Wait. What's going on? I do not know. I hope you enjoy my head being low down in the thing. Actually, the monitor is really taking up a lot of the view right now. It's not good for the Weissman score. Okay. Now I can chill. Oh, the arrows are in the wrong direction. So we're from string to float, and then we're from simple string. See, now we crash without maybe it was that the amount is screwed up and we weren't printing it before. I don't know. That doesn't seem likely. But you're supposed to be able to advance 4 when amount is 4. Where are we crashing now? Did we just mess up the stack enough that we're crashing somewhere else? Or mess up. Did we just change the composition of the stack enough that we are crashing somewhere else? It's possible. Oh, we're just like straight up crashing now. This isn't even. Okay, I can't, guys. We have Visual Studio not liking our incorrect debug info enough that it will not respond to button presses. Actually, Control-Alt-Delete does not work either. So I cannot. Oh wait, wrong button. Sorry. Okay, which Visual Studio is it? I'm sure glad Steam uses so many web helpers, by the way. That makes me happy. Also, I sure have a lot of con hosts. Like, what are all those? Just is it under M? Where is it? Why is there an MS build running? What is even happening? Who's mining Bitcoin on my computer? Acro tray? Yeah, we don't need that. But like DevEnv, right? So we'll pick the one with the highest process ID. There we go. We got it right. Okay, so now it's just crashing. And the problem is that I'm paying for my sins. That sin being that I didn't fix the debug info. So now things are extra. Now we have a bug and we can't debug the bug. And normally I would be fine because I'm just like, we'll just run LLVM. But the LLVM backend doesn't have the bug for some reason. It said triggered breakpoint. No, that I don't think this is an assert. I think this is like it crashed. But it sure does look like it works usually. It's a little bit suspicious that we're advancing by decreasing numbers. What's going on with that? These look kind of suspicious too. Okay, since the caller is 1306, we'll do this. Secret trick number 2. Wait. Oh, it's in string. Here we go. We'll pass the location. It's like passing the salt at dinner. Please pass the milk, please. See, we're getting errors and stuff. It is definitely not working correctly. It's just not crashing usually. Look at all these. Now it's just going. So it's something about the stack case it doesn't like. I probably just did something really bad. Actually, no, this looks like it's running fine. It's just doing a lot of operations. Can I look at the assembly? Maybe not if Visual Studio crashes and doesn't let me look at the assembly. It could be infinite looping. Maybe the offset is too big for the instruction using an x64. Shouldn't be, but might be. It's possible. I don't think so. Can you run with no debug info? Maybe. We could also manually delete the PDB. Right? Like, this is just going and going and going. It looks like it'll finish eventually. I mean, the solution may just be to fix the frickin' debug info next, right? The problem is, like, I don't like to switch gears, and I don't like to do it especially when I'm, like, not checked in for a while on non-trivial things. But it is definitely... It is definitely possible to do that. I mean, okay, it seems pretty clear that I'm dereferencing an incorrect address on the stack. That just goes without saying. It seems likely that it's in these bottom two functions. Why don't I just do a dump on them? It might just be a thing where LLVM happens to do the right... I don't know. Hold on. So here we're definitely saying... We're using the register value as a pointer. We're adding a number to it. Oh, yeah. Okay, hold on. I know what it is, guys. Whoever said it was a size problem in x64 was a little bit correct. It's this move 64 should be a move extend. Because we were always loading 8 bytes and then storing that. And I'm not sure that was the problem, but it was not correct. Let's put it that way. I don't know that that's exactly the problem. Let's take our print statements out for a little bit. Actually, let's just do this just in case. Move extend indirect doesn't take 7 arguments. So it wasn't really things being too small, but not doing size correctly. Output, register, offset, size, signed. Oh, this is always into register. Dang it. Didn't fix anything. What happens after the case statement? After what case statement? Oh, like down at the bottom. Probably nothing. So why do we break, do you ask? Well, because I thought a long time ago that would be the way to structure it. Yeah, it's true. The one above returns instead of breaking. Yeah, nothing happens down there, so it doesn't really matter if we return or break. I mean, we can break to be consistent. We could assert some stuff about the offset. Hmm. Let's actually even comment these out for a sec. Okay. V4 gets V1 subscript. That's the count. V4 minus V2, that subtracts them out. Move V1, V5, yeah. Yeah. V6 is V1 plus 8. That's the data. V7, V6. Yeah. This looks correct to me. So guys, this feels to me like a bug in the x64 register allocator stuff that, again, like this happened earlier in the week or whatever. We had a bug and it was not really exposed by anything for a long time, right? And it made things very confusing when it came up because I was like, hey, what's going on, right? And it turned out to be this register allocator problem. Now, is that what's going on here? I don't know. Why don't I know? Because we can't really look at the assembly. So I could try the deleting the PDB problem. And if that doesn't work, we could try fixing the debug info. The problem is that's not fun because I have no idea what's wrong with the debug info. And I don't remember. There was like something that we ran a long time ago that really helped. And I don't remember what that was. Okay, guys, the game works fine. What are you talking about? Is there something about the debug info being messed up that could mess up the executable? Or is it just that I commented out those assertions? Are the assertions triggering the code gen bug? Was it compiling incorrectly because it had an old corrupted PDB and then I deleted the PDB? I don't really have a theory yet for what is happening, and that's a scary thing in computers. It could be that it compiles inconsistently. And sometimes we generate a crashy executable and sometimes we don't. But it sure seemed to crash all the time before. Was it a tool that was like obj dump? It was something like that. Okay, hold on. Maybe we changed one of the modules. Because I was like editing them. So let's go revert Windows resources. That probably doesn't matter. And we'll rebuild. Okay, let's get rid of our changes to string, right? Because that's not, shouldn't really be anything. And then we do the other one. And there really isn't anything, like there's just the dump in theory. Well, there's a caller location argument as well that is not being used, but is being supplied. But that has been there for a while, so I wouldn't expect that to be the problem. But it could be. Like that would be information. Let's find out. It's also not saying debug information corrupt. Do you notice that? I feel like this might have been a toolchain issue of some kind. Release versus debug again? No, I mean, oh, it is. Oh, shit. Yes, we're building with the release compiler, guys. It's been a long day, and there's so much yet to fix. Okay. Okay. I admit that was stupid. Now it's going to crash. Thank you. Thank you. I actually like that it crashed. I actually like that it crashed. Because now the world makes sense. All right. Interestingly, though, it wasn't saying corrupted debug information with the release compiler, which it should have been. Did it say it here? No. So maybe we could actually debug now. No. I mean, yes. So well, We haven't made gains in a little while. We are supposedly close to significant gains, but we've been struggling. We've been on the struggle bus. Okay, let me re-verify. Since I was just running the wrong compiler, I think I was doing the right compiler with all the LLVM stuff, but we're just going to run it again because when in doubt, just figure it out. Now I could do the PDB deletion thing now. I don't remember what tool we were using. Was it objdump? Was it dump bin? I thought we had something better than dump bin. Kernel history doesn't go that far? No, it doesn't. We're talking about stuff from months ago. We might have to take a break so that we can attack the bug snacks with renewed vigor. How long we've been going? We've been going 4 hours. It seems like a lot longer. Seems like 7 hours. The thing that I am inclined to do is try to fix x64 debug info. Wasn't there like an LLVM tool for viewing PDB? Oh, it was on the, it was CV dump. That's what it was. It was one of the programs. Maybe I did it on the laptop. CV dump. Download. Did I put it in bin? Wait, why is it? No. Bin. Well, downloads. CV dump is going in bin. All right, let's try this. Okay. Dash headers, let's try that. Okay. Section headers, text, our data, data. Now the big change I made, I changed the BSS segment. Why is there no BSS segment? That's probably the problem, guys. Because I changed the other day. Okay, actually, we don't... we want to see the obj file. Actually, let's make sure that we just built the game with the debug compiler. Oh, and then we spill T everywhere. Let's make sure we do that. Why have bug snacks only when you can have bug snacks and T on the floor snacks? It's just so much better. Okay, we compiled. We're outputting. Debug information not found. All right. I guess we have to obj dump then. Text our data. Data. Maybe it's complaining that we add the section header, but we never add the section. Okay, let's look at the history of this file. Because I made what seemed like a relatively straightforward change at the time, and it did corrupt the debug info, and I was like, oh, I'll fix it later, but now I'm really paying for that. And I have to fix this before we ship the beta anyway. Okay, notice that combine leave functions. Don't put... Wait, this is not... Hold on. This file specifically... Windows is so bad at picking files. Show log. All right. Cosmetic name change. BSS is now a new data segment. This is probably the change that hosed me. Was that really only 2 days ago? That's crazy. Okay. So we're asserting now that these are the same size, but we're modifying the same thing in the same place. And that's some macOS thing that's not even running right now. What the hell is a Visual Studio command developer command prompt? God damn it. All right. What? Where the fuck is obj dump, guys? Or dump bin? Dumb bin. There we go. Headers. Oh, it's there. socodebug.obj 2:06 p.m. That's probably the right one. So this says there is a BSS. Or not, it's pretty large. Not as large as some other sections. text, R data, data, CFG. I don't know what the hell that is. GFIDs, retpline, TLS, types, reloc. Ah, see this DBI open debug failed. That could be bad. It could just be Microsoft Tools being Microsoft Tools. I don't know. It seems bad. That said, their error message has 2 commas with nothing in the commas. So like, what am I supposed to do with this? Running LLVM read obj. That might be the thing. Do we have that? No. Deleted all the binaries, sorry. Maybe that's what I ran last time that was good though. Just give me a binary, guys. I don't want to fucking spend 3 days compiling LLVM again. Oh my God. Version 4.0.0. Hey, I'm not going to download something from that site. Do I dare download the pre-built binaries? I did that before and it wasn't good, but maybe they weren't devel binaries. Now I'm going down the 5-hour rabbit hole of this not working. Okay, let's try this. It's not in there, guys. They don't give a shit. They made pre-built binaries. They didn't put that in there. Hello, everybody who is rating me while I'm trying very hard to get annoying, stupid things done. LVM obj dump. Now it's like Windows file completion trolling me, right? Hey, we got a thing. Okay. Dash headers Okay, let's see what happens. Well, that's very boring. Maybe we dump more. Dash dash code view. On the PDB file. Right. Ain't no dash dash code view. Banana bread. I want banana bread. Why don't I have banana bread right now? All right, guys, I don't know what you're talking about with dash dash code view. That's just not a thing. Baking stream, well, definitely no LLVM read obj. So now they're saying dash S. People are giving me random things. Should I do it on the PDB or should I do it on the obj? All right. That's dash S looks like disassembly, guys. Or not disassembly, but like dump the entire frickin' file. Well, this is not LLVM read obj. This is LLVM obj dump. They don't care enough about me being able to do anything to put read obj in the thing. As of 3.4, dude, LLVM is on version 11. Do you know how many time zones there are in the Soviet Union? 11. This claims it's in there. Dude, I just want anything doing with LLVM, I just want to punch into outer space. Like, I hate literally everything about it. Like, I could recompile LLVM. I think I might, because I built LLVM on my laptop, there is a possibility that I have whatever binaries, because It was already huge to check in all the files with debug and stuff, but I may have kept binaries locally. It's like, guys, you just can't have a culture where you build everything from source when it takes 3 days of hard, grindy work to build things from source. That's just not acceptable, you know? All right, LVM 11. I have some binaries. There is an LLVM obj dump here. That's what we're looking for, right? No, wait. It was read obj? Which one are we looking for? I have both. I have both. There is no read obj here, but I have one here. You want read obj. Okay, I have an LLVM read obj. Yeah, I didn't check any of these in because they're freaking giant. I have an extras folder on my laptop. It is 3.42 gigabytes. Can you wonder why I didn't check it in? How about, what about just the release with debug info? 762 megabytes. LLVM read obj. Let's put it on Dropbox. Why do they keep making Dropbox worse? I just want to open my Dropbox folder. I don't want your stupid thing. Like, how do they not understand that the good part of Dropbox is that it just integrates into your file system? All right. LVM read obj. Bin. What? Are you trolling me? Oh, I put it in there. That's the wrong place. There we go. Okay, it's reading from standard in because it is a Unix program, I guess, or it's just crashing. Okay. It was -- code view, right? Okay. Okay. The stream is too short to perform the requested operation. That means it's parsing the object file, right? Somebody is referring outside the file. Why don't you tell me who was referring outside the file? Like, that's the whole reason that we're doing this. Oh no, Emacs is scared of a 9 megabyte file in 2021. To be fair, Emacs is so slow, it should be scared of that. I'm reading the obj file. Yes, because that's the only thing it would run on. I tried running it on the PDB. It wouldn't do it. Guys, I'm doing whatever I can do here. I have no idea what's going on. I'm just trying to figure out what the fuck is the problem. Okay. I've got all these leaves. I'm very excited about that. Look at all these leaves. Look at all these leaves. All right. Error. I want this thing. I don't want me saying error. I want this program. The problem with the word error is too many people use it. I mean, oh my God. Don't worry, we're a third of the way through the file. And I might have skipped it. Stream error. Nope. See, it's writing that to standard error. So I have no idea. Literally no idea. Like if it wrote it to the same stream as the output, then I could tell where in the output it was. This is the most useless, stupid thing. Check the end. Okay, that's a reasonable suggestion. Oh. Okay, so it quit when it hit this debug.$S section. I mean, I didn't really edit anything there, but maybe again, it's a bug that was exposed otherwise. Debug $. So debug $T is correct. Debug $S is sad, maybe on the very first thing. I don't know what goes in debug $S. 2 to and 1. Maybe it works if they flush everything at the right time. Right. The problem is these are like asynchronous. Even if it puts it at the end, that doesn't mean that's really where it is. But I believe it is now because of this, the fact that this just cuts off, right? So whatever the first thing is that we put in debug $S is out of range. Or maybe it does a first pass on all the symbols and then prints them in the second pass. So like maybe it's not the first symbol. Like, guys, error messages like this, they're so bad and they waste so much of so many people's time. Like, look, what could you do? A, tell me the index of how far you're trying to search so that I can look for that number in the binary. B, tell me the offset into the section of the thing that's wrong. Like if you take all the errors of this form and just fix the error messages to give more information, Programmers will be between 3 and 5 times more productive globally. But we don't care because we don't care if people ever get any work done, apparently. This is LLVM version 11, guys. Nobody bothered this for 11 versions to make these error messages better. If I breakpoint that error and debug read obj, are you joking? It's going to take me 3 days to compile LLVM on this machine. And the actual debug executables for LLVM are so slow, I can't even run them. You have to run release with debug info. That said, it actually probably won't take 3 days because I figured out all the commands, so it'll probably just take a few hours. So we might resort to that, actually. All right. I am in a bad mood, as you guys can tell. I am in a very bad mood right now. Because this is the part that I hate. I hate that LLVM is not giving me the very easy information that could make this easy to solve. I hate that the operating system is not giving me that information. I hate that Visual Studio is not giving. Nobody out of how many thousands of people worked on executable loading in Windows? How many thousands of people work on Visual Studio and LLVM, and none of them give a shit about helping you when an object file is wrong? How many millions of billions of dollars of salary were paid to all these people? So when we looked at the headers here, someone said, look at the header. The $S and $T were the same size. Actually, they're not here. They were in the final executable, which was weird. I, of course, at this point, don't remember what command this was from. Not many people build their own object.exe files. Yes, but the people who do, their productivity is very, very critical because they're building the system tools that everyone else wants to use, right? Like, it only would have taken like 5 minutes to put more information in that error. And you would, even if you only save 100 people 10 days each, that's an incredible amount of savings. Like the power multiplier on things like this is not to be underestimated. You think that was from dump bin? It could have been. That is objdump/headers on Soko debug. Okay. So, I mean, it looks like a pretty reasonable section size. So we must be writing something invalid. Okay. I don't submit pull requests. If I do work, it's because I know that that work will go into something. I don't request people to please take my work. That's a waste of life. Are we back yet? Are we back? We had a F. We had a Twitch F. And, oh, it says it's green now. Okay, so I'm going to just try... I'm going to try looking. And if after a little bit of looking, I can't find it, then we are going to take a stream break. And I'll just compile frickin' the LLVM programs on this computer, which will take an hour or two. But that can also, like, hopefully the ideal case is it just takes an hour to compile and the commands all work the same the first time and I get what I want out of it, right? It might also be several hours of me banging my head against the wall again, trying to make it compile, but hopefully not. Hopefully that was all done over my Christmas vacation. So you'll never know why I don't submit pull requests. The idea of a pull request is offensive, kind of, right? It's like, hey, go do all this work. And then the guy, you can submit to me your request that I pay attention to your work. And then the guy who decides what goes in, will decide to take your work or not, right? And if I decide not to, then you wasted your time, right? There is inherently, like, everyone pretends open source is super democratic, but there's inherently a very strong class structure there, right? So if you submit pull requests, you're kind of lower class in a sense, right? Especially on a giant project like LLVM. And I don't know, like the fact that I think they have such bad taste in everything. There's something very negative about submitting to the judgment of people who you believe have very bad taste. Do you know what I mean? If that makes sense. What's the alternative to pull requests for open source? Just let everyone commit whatever? No, have some kind of mechanism by which you admit trusted people and then just don't take contributions from other people. I don't know how you work that out, but you work that out somehow. I think that would result in higher quality and much less friction. That's what I would do. However, I'm not running an open source project. Okay, so this is our debug $S section. Thanks for the help, guys, about figuring out what program to run and what option. It was frustrating to get it running. I guess we're back again after the F. Thank you. I was saying thanks, guys, for pointing out readobj and the code view option. Let me put that in notes. LLVM readobj dash code view on obj file to find errors. Going to record that information. Yeah, it's like for anything the level of complexity that LLVM or whatever is, either people really know the code and can contribute, or they barely know the code and it takes more effort to make their stuff usable than is worth it. It's like you could have just done it faster, right? And that's sort of the flaw in the open source patches welcome model. Is it doesn't exactly conceptually make sense. Are we planning to get rid of LLVM eventually? Yes, but that is in the far future. Okay, so debug $S is unhappy. That's probably in the other file. Code view debug info. Where do we get it from? Add section header elf. No, that's obviously not us. No, it is. Okay. So, I'm confused deeply here. So we won't worry about it. If there's a bug for code view on Linux, we can test that separately if I can get that going. All right. So it's just add section header here, it doesn't have a cough prefix because it's the function that I wrote originally. Here we go. I mean, I could just step through and just see if we write anything that looks bananas, right? It might not be obvious, but it might be, right? Wait, this is add section header. This is not. Okay. Right. That's just putting the header information. So where do we fill the data? Here. So like, we have the section, the magic, and then if it's like $T, then we just start with these structs, right? And so it's going to be in code view write compilation unit. I hope that didn't do a bunch of stuff. Probably not. All right. is the string table the $? T? So debug info segment is the $S. I think. I think the idea was if we support code view, why not support it on both? But honestly, it doesn't seem very important to me. Since nobody ever uses it, I would rather just not deal, right? Okay, hold on. Let me go back to here. It's been a while since I've looked at this code. Yeah, so debug info segment is what we're looking for. So this adds the version. And not really much else. Oh, wait. Type info segment. Wait. This might be where the thing happens, actually. How much data do we have in here? Um, 40 something. It might be the very first thing that we write out. I don't know. I honestly... Like, this could be a wild goose chase because this error could be that there could be like 37 things in because it's literally printing nothing. Like, you could imagine that they're passing just an array of types to some serializer library and it's complaining in the middle. I don't know. Okay. Let's just see, though. We're going to start all over again because code view setup is actually writing some stuff. And we'll just see if that looks reasonable. Okay. It's fine. Code view version. Okay, that doesn't actually write anything. Right, let's verify. The point is 4 bytes in front of the start. And I don't know what the magic is supposed to... Is that stored here or is that stored there? It might even be saying that the offset, like this, it might be saying that it can't even get to the start of the data, right? Code view write type info didn't do anything. Oh, we're in the debug info segment right now. So it wrote to the other one. So none of this is changing the debug info segment data. So now we pad 4 more bytes. Wait, that's already wrong. Guys, we were on a 4-byte boundary. Why did it add more padding? Doesn't that seem wrong to you? Dost that not seem incorrect? I didn't change padding though, that I know of. Oh, I did change padding. There was a bug in padding. And I, quote, fixed, quote, the bug. And maybe that's when this broke. Okay, let's see. Pad to alignment. Yep, I totally edited this function. Okay, position 4. Remainder is going to be 4. Yeah, okay, I screwed this up. Actually, let's just put, it'll be more obvious if it's remainder 0. I totally edited that function. Okay, so this was again a thing that was confusing because I sort of in the back of my head thought that I knew which commit somehow had broken it, and it totally wasn't that one. It's just, I guess it took me time to notice or something. All right. Let's just run release compiler and debug compiler. I could have, I could have binary searched the repository to find the one. That's a time-honored technique. Okay. Now, I assume it's still going to crash if we run it because we didn't find the actual bug. But let's make sure it crashes. Okay. But we should be able to debug it. Look, we got a call stack, guys. Okay, this is great. This is also good because that's one of the things that I absolutely had to fix before shipping a beta to anyone. So that's good. I certainly had an hour of being grumpy. Okay, so now we actually have the capability of looking at our machine code and all that and finding the problem. Because I suspect it is a register allocation problem in x64. All right. So we are back in full debug power. Except I don't know what all this is. Like what are the question marks, guys? Okay, hold on. Let's just do this over again. Yeah, okay. So we're fine. And when we go up, yeah, okay. So I just kind of have to look at all this code, which is still more than I would like, and figure out why it's wrong. I do not, oh, wait. Like it's doing this thing where the decoder is off up here. I don't really understand why that is, because it looks right down here. Is that just a Visual Studio bug, like the disassembler like desyncs? Because it's fine down here. And then just like somewhere around here. Or maybe we're just outputting screwed up code. I don't know. It's definitely possible. All right, I'm going to leave it there and take a break, but this is good news. It's just the Windows background draw, usually the brush black. That is a good point. I don't want to do that right now, but remind me of it sometime when I'm not like 3 bugs deep in trying to get back to sanity, and we can do a quick thing and do that. Search for push RBP. We do not emit any RBP right now, and we should. Like, we use RSP for everything, which means it's kind of a royal pain in the butt to do like Aloka or anything like that. So, well, not only royal pain in the butt, it's impossible, actually, I think. So we need to switch to RBP at some point so that we could do that. Yes. Okay. Thanks everybody for coming by. We had some frustrating times, or rather I had some frustrating times, but we also persevered. We got some things done. We are most of the way through this struct revamp where we're going to get some more gains. The gains have not been super high magnitude today so far because we got in this frustrating mired spot, but it'll make it nice when we get out of it. We might, I think we still have a hope of breaking 350 today. We're just going to have to see how it goes. Do you just know how much stack size you use? Yes. Yeah, so we don't change the stack except statically right now, right? So at the end of the function, you just subtract everything that you added, and that's it. Thanks, everybody. I'll be back later on after a break. Bye-bye.